Hello everyone. In this video, I'm going to show you how you can avoid complex branching in Java using the strategy pattern. And to illustrate you how you can do this, I'm going to show you an example using a path-finding application. And a path-finding application calculates a route between point A and between point B, so between 2 points. In this case, you can calculate a route using the red dots or using the green dots. Now let's have a look in Java how we can manage this. So we have our class, the Pathfinder class, and for each algorithm that you can find, so when we go back, there are several algorithms, the Dijkstra, the A star, so each of them have a different method of calculating from point A to B. So now let's imagine we go to our Java application and we actually start creating one method for each an individual algorithm. So as you can see here, we have the BFS algorithm, DFS and Dijkstra and A star, and each algorithm will have its own implementation from point A to point B. So when we would have a new algorithm, we would simply copy this method and we have a new algorithm. Now, we don't see any complex branching yet, so the problem occurs when we want to use this algorithm in practice and when we want to introduce a new method called the findPath method. And the findPath method takes an algorithm, a start and an end, and here you see the branching. So you start with an if the algorithm equals BFS, then go for the first method, otherwise go for the second, depending on the algorithm. Now, when I need to use, or when I want to use a new algorithm, I have to extend the if-else branch, and it can become quite long. So let's see how we can improve this using the strategy pattern. But first of all, let's create a small main method and see what this actually does. So I'm just gonna create a main method. We create a path finder, and the path finder finds the path using the different algorithms. So let's run this. As you can see, we execute BFS and the path was found using BFS, DFS, executing DFS, and we all have this. So how can we improve this using the strategy pattern? Well, first of all, we're going to introduce a path finding strategy. And a path finding strategy, it encapsulates the core concept of what you want each algorithm to do. So I'm going to go into IntelliJ right here, and I'm going to create the path finding strategy. And it's going to be an interface because for each implementation, we just want to have the path finding. Okay, so what is the base of our algorithm? It's to have a find path. So it says list of string, find path, and then it starts with the string start, the first point, and the end. And this is our simple algorithm. Okay, we just need to include the class right here. And each different algorithm that we're going to use is going to extend this interface. So let's create our first implementation of the A star algorithm. And it's a class and it implements the path finding strategy interface. So here, what we do is we simply go back to our path finding right here, and we copy the A star, so the implementation, we simply copy paste this into the path finding strategy for A star. Okay. All right. So now that we've done this, we have to do the same thing all over again for all the other path finding algorithms. So I'm going to do this right now. So we just created all of the different algorithms for each pathfinding algorithm we want to support. So let's go back to our pathfinder and refactor this code. So I'm just gonna throw it all away like this and start over. The first thing we want to do is to make sure that the pathfinder itself uses the strategy. So I'm going to say which strategy are we going to use, and it's a private instance variable. So it's going to be pathfinding strategy, and it's a strategy. And we're going to create a getter and a setter, or just a setter to make sure that somebody can change the strategy. Now we have the method public list string of find path, which starts from a start and an end. And what we will do now, using the strategy pattern, we will just delegate this method to find a path towards the strategy. So we say return strategy dot find path start and end. So what you see here, we have by delegating to the strategy pattern, we avoid using if-else. And if you want to see how this would work, then let's just create a new main method. And first of all, we create a pathfinder. The pathfinder right here. It's the wrong one, of course. Let's take this one, pathfinder, a new one. And first we want to set the strategy that we want to use. So we're going to say set strategy new the BFS algorithm, and then we're going to execute the path. So I'm just going to simply copy paste this from here. So path found using BFS, and it's A and B. And what we can do is we simply copy paste this. So I just added all of them. So we have BFS, A star, and Dijkstra. So when we execute this and we run the pathfinder, it simply is going to work. Just take 1 minute. And here we have it, executing BFS, start to end, using BFS, A star, and Dijkstra. And of course here we need to change this up a bit, A star and Dijkstra. And re-execute this. And here you see Dijkstra, A star, and BFS. So this works just fine. Next up, I'm going to show you how you can use this strategy pattern using an enum. 5, 4, 3, 2, 1. We can even make this a little easier by defining a new enumeration. So I'm just going to create a new Java class. It's an enumeration, and it's going to be called the pathfinding strategy type. And the type will indicate if it's an A star, a BFS, or other. I'm just going to create it. And the first thing that we're going to create is, again, our little instance variable of the strategy that we want to use. So it's pathfinding strategy, like this. And we also, for each enumeration, we want to have this in the constructor. So it's a required field. It's a required instance to have this in the constructor. We also want to have, of course, a way to access the strategy that's being used. And on top, we can define all the different enumerations that we are going to use. So first of all, we're going to say A star. It's going to use the new A star pathfinding algorithm. If we want to have BFS, Then it's going to use the BFS pathfinding algorithm, pathfinding strategy, like this. And the last one is the Dijkstra. Just the same, you Dijkstra pathfinding algorithm. So by linking this, you actually made a static link between an enumeration and the algorithm. So let's go back to our pathfinder, and we are going to change the find path a little bit. So first of all, we can just remove the pathfinder or the strategy within the pathfinder, and we simply pass the type, so pathfinding strategy type, inside this method. Now we're going to ask the type to get the strategy like this, and then simply execute the path. So we can remove all of these methods to specify the individual strategy, because now it simply knows. We don't have to do anything anymore. So we just removed all of the individual methods, and we can use the pathfinder where we, instead of pass the type, we simply have a new variable here, and it's going to be a star. So we're passing a star because it's BFS. So we're going to start with BFS. Then we have a star like this, and in the end we have Dijkstra. If we re-execute this block, then we're gonna see we have a small method, a small error here. We're just gonna rerun it, and we have again our existing code. So BFS, it starts with BFS a star, and without using any specific if-else branches. The cool thing about this is that using the enumeration, you're actually linking an enum with its strategy implementation. And that makes it very easy and very programmer friendly to have something like this. You define the pathfinder, and then you simply pass the type of the algorithm that you want to use, and everything works without using any if-else branches. If you want to know more, visit javadesignpatterns.com or go to javanauts.dev to join the developer community.